One of the most prolific sounds in the music of the past 80 or so years, from the early big bands to the Beatles to modern pop music, is the electric guitar. Have you ever wondered how one of these creates sound? How does this turn into this? Well, that's exactly what I want to talk about today. I'll begin by describing how an electric guitar produces an electrical signal. Then I'll discuss the role of the amplifier in that signal chain, and finally discuss how a loudspeaker translates that electrical signal into an audible sound. So the electric guitar takes the frequency of the vibration of the strings and detects them by these magnetic pickups. Now I'll bring the guitar closer for you to see. These magnetic pickups are composed of 6 pole pieces, each located directly underneath one of the 6 strings. In addition, there is a coil of copper wire surrounding these 6 magnetic pole pieces, which is actually underneath the frame of the guitar, so you cannot see that visibly right now. But the role of that I'll discuss in a minute. The guitar string is composed of steel, and when it vibrates, it disrupts the magnetic field generated by these magnetic pole pieces. This disruption of the field actually generates a current in the coils surrounding these magnetic pole pieces. This is a result of Faraday's law of induction. Now, this electrical signal is then sent to the output of the guitar into an instrument cable, which is sent to the amplifier. Now, the instrument cable does not provide any power to the electric guitar, so that signal is very weak. So, as the name suggests, the amplifier's role is to amplify that weak signal into a larger amount or value, which can drive a loudspeaker. So if you imagine the signal generated by the electric guitar is a very small oscillating signal, then the amplifier will take that signal and magnify or amplify that to a larger value while retaining the original integrity of that signal. However, amplifiers may be composed of vacuum tube technology or transistor circuitry, and each of those introduce their own character into the signal themselves, which will produce a little bit of a different quality or type of sound, which is really up to personal preference on what kind of amplifier you purchase. Now, the output of the amplifier is then fed into a loudspeaker, which I'll show a diagram up on the screen for you. You can see that the speaker contains a cone which is connected at the base to a coil of wire. Now, this coil of wire is situated directly in front of a permanent magnet. When the coil of wire receives the signal from the guitar, the coil actually generates an electric or a magnetic field which either attracts or repels that permanent magnet. This causes the cone to actually move forward or back according to that attraction or repulsion. Now, the frequency of the vibration of the strings will move back and forth, causing the electrical signal to change directions. Therefore, when the coil actually receives a signal in the opposite direction, that magnetic polarity is reversed and that attraction or repulsion flips, causing that speaker cone to move in and out on the order of hundreds of times per second, which is corresponding to the frequency of the guitar strings vibrating. This will actually create differences in air pressure surrounding the speaker, which actually creates an audible sound. So there you have it. There's a basic overview on how an electric guitar produces sound. I described how an electric guitar produces an electrical signal, how an amplifier takes that signal and magnifies it to drive a loudspeaker, and then how a loudspeaker transforms that electrical signal into an audible sound. I hope you learned something, and I highly encourage you to pick up a guitar yourself and create some of the world's best music.